This is the graph that's on the front of your yellow worksheet, ISN 11-2. I've taken some of the stuff off of it so we can focus on the graph. Also, it wasn't real clear from the graph that these are your x-axis and your y-axis. Does this look like kind of the graph that you were graphing on Friday? This is a rational graph, a rational expression, and it has some asymptotes. Did you understand from Friday's lesson what an asymptote is? Okay, let's go over what an asymptote is. Do you see that this graph is, the asymptote on the graph is represented by dotted lines? And this graph is getting closer and closer and closer to this dotted line. Why is it getting closer and closer and closer to this dotted line? Well, what would the equation of this one be? So, the equation of the parent graph is 1 over x, and this has been shifted 1, 2, 3. So this would be x minus 3. Why is it minus 3 if it went to the right? X is still a liar. This parent graph would have an asymptote here. This has been moved over 3. The parent graph would have an asymptote here. It's been moved how much? And it's been stretched. How do you find out the stretch? How do you find out the A? Do you remember that from the lesson on Friday? Not rise over run. For this kind of graph, the A is equal to rise times the run. Well, where do I count that? There's a pretty point. It rises up 2 and runs over 1. So this is 2. That's the equation that goes with this graph. The asymptote, this asymptote comes because the denominator cannot be equal to 0. One place that the asymptotes come from is the denominator cannot be equal to 0. We were calling those excluded values. Do you remember when we were solving the equations, we wrote down what x cannot be equal to? And those become asymptotes on the graph. Now here's what an asymptote is like. Many of you have seen a picture of my grandkids up there on the screen sometimes. Samuel's 3 years old. Is he allowed to go in the street? Of course not. You don't let a girl go in the street. And so, he has been taught he cannot go into the street. So you know what he does? He goes right up to the edge of the driveway. At the edge of the driveway, there's a little crack. The driveway meets the street. He goes up to the edge of that, and he moves his toes closer and closer and closer to that little crack at the edge of the driveway. But do his little toes go over that line? They do not. That's what an asymptote is like. Getting closer and closer and closer, but never going across the line. Because he knows that disaster is going to happen to him if he crosses over that line. He's tried it once or twice and found out it was a bad choice. But on our graph, they can't go over the asymptote. Go as close as they possibly can without ever touching the asymptote. So that's what an asymptote is. The graph gets closer and closer and closer and closer, but it cannot ever touch the asymptote. So does that clear that up a little bit? So what we are going to be doing is, you can see on the yellow paper there's a whole lot of writing, and I'm going to be going through and explaining each one of the attributes of a graph. And so what we're going to do by Wednesday, not all at once in one day, we're going to learn how to figure out all the parts of the graph. And then Wednesday, we're going to take and put them all on the graph to make a beautiful rational graph. So, this little chart is to help you figure out all the parts of the graph. Here's the good news. We're not doing all of it today. Today, we're going to focus on the x parts of the graph. Guess what we're going to focus on tomorrow? The y parts of the graph. And then on Wednesday, we'll put all of the pieces together on the graph paper. So, did you get this when you factored example number 1? The first step is to factor. Now, this one does not have a hole, so you're going to write the word none right there. When we get to an example that has a hole, I will show you how to figure it out. So, pick up your pencil and write the word none there. This graph does not have a hole. Now, do you remember finding the excluded values? What would be the excluded value if we were solving this? X, -2. The reason it's excluded is because that's where the asymptote is. And so x cannot equal to -2. The denominator cannot equal to 0. Where it does equal to 0, what that makes is an asymptote. So, if I solve that out and divide by 3, and then, I don't have much room, x plus 2 equals 0, subtract the 2, x cannot equal to -2, that's where the asymptote is. The same thing that we were doing previously in calling excluded values, what happens at the excluded value is an asymptote. Okay, now we're going to skip this. Oh, there's something else I need to tell you. I have always gotten vertical and horizontal mixed up. So you've got to help me. If I say the wrong word, you have to correct me. And you will see me waving my hands around a lot. If I'm waving my hands up and down, what is that representing? Vertical. If the line is up and down, vertical, it's crossing the x-axis. That's why this equation is x equals. Tomorrow, when we get to the horizontal asymptotes, and I wave my hand from left to right, that's reminding me horizontal. And if I say the words backwards, you have to correct me. If it's going horizontal, it's going to cross the y-axis. That's why this is going to be y equals. So y'all got to help me keep those words from getting mixed up, because I've always gotten mixed up. Okay, now that we're going to skip this and come back to this tomorrow, and now we're going to do the x-intercept. The x-intercept is a point on the graph where the graph crosses the x-axis. And we solve the numerator for 0. The numerator, this numerator, where that's equal to 0, that will make the x-intercept. So, where's the x-intercept? The x-intercept is a point on the graph at 2, 0. Now, you don't have a graph paper on this page, but what's coming next is to put all of this on a graph. We're going to put the asymptote that we just figured out on the graph. We're going to put the horizontal asymptote. We're going to put the x-intercept on the graph. And we're going to fill in the graph. And when we fill in the graph is going to look something like this. It's kind of like those graphs that you were doing on Friday. And it's going to look something like this. How far, I'm getting ready to do the domain in case you didn't know where I was going with this. So domain, do you remember domain? It's been a long time since we talked about domain. What's domain? X direction. How far is this going in the x direction? This way. How far is it going in the x direction? This way. And so it starts here and it goes in the x direction, but it goes way up high there. But does it touch the asymptote? It jumps over the asymptote and goes way down here and picks up again and goes how far that way? So it goes from negative infinity and jumps over the asymptote, and then it goes to positive infinity. Write that with math language. It starts at negative infinity, and it goes up to the asymptote, and it jumps over the asymptote, and it picks up on the other side of the asymptote and goes to positive infinity. This parentheses here means it goes up to the asymptote but doesn't touch it. Parentheses here means it goes up to the asymptote and doesn't touch it. U means it's the union of two parts. When we have my graph over here, does it have two parts? Are they connected? No. That's my reason why my domain has two parts with a space in between. And U means union of two parts, this part and that part. Now, we're going to come back and fill in the rest of this chart tomorrow, so don't lose it. So skip over to the beige colored paper for example 2. Did you factor example number 2 correctly? To get started, the first thing you do is factor first. So, what are my excluded values? And so my excluded values are -1 and +3. My excluded values come from the fact that the denominator cannot be equal to 0. Where it is trying to be equal to 0, that's where we have an asymptote. So instead of saying x cannot equal to 3, we're saying the asymptote is equal to 3. Where you have an excluded value, that's where you have an asymptote. To find the x-intercept, you take the numerator and put it equal to 0. How do you solve that? 2x equals 1, divide by 2. What's the x-intercept? That's a point on the graph. The domain is going to be everything except the horizontal asymptotes. You have to stop and think. So it's going to skip over the asymptotes. It's going to start at negative infinity, and it's going to come up to this asymptote and skip over it. And it's going to jump to the other asymptote, and it's going to have this little section in between the asymptotes, and then it's going to jump over the next asymptote. Now, this is probably a little foggy. It'll clear up once we start actually putting it on the graph. Just understand that the graph has to skip over the asymptotes. And when you write the domain down, it has to be in order from smallest to largest. That hasn't changed since August. We got that much? And we're going to come back to graphing it later. Example number 3. Did you factor example number 3 correctly? When we were multiplying and dividing, what was the first thing we did after we factored? Canceled. Is there anything that will cancel here? Did something? What canceled out? Where x plus 1 equals 0, where the canceled out part equals 0, that's where there's a hole in the graph. Where the x plus 1 equals 0, that's where there's a hole in the graph. And so where's the hole in the graph? X equals -1. This is a point on the graph. That's just the x value of the point on the graph. What else are we going to have to figure out? The y part, but we're doing the y's tomorrow. So we'll come back to that, the rest of this tomorrow. The vertical asymptote comes from where the denominator equals 0. This part is already canceled out, so I don't have to worry about that. It's the denominator that's not canceled out that gives me an asymptote. And so where is the asymptote at? Now, canceled out. So this part of the numerator that is left, where that's equal to 0, that's what the x-intercept is. How do you solve that? What would you do first? You would do what? Okay. So if you divide by 2 and then add 1 to both sides, and so the x-intercept is at 1, 0. Now, not only is the domain going to have to skip over the asymptotes, it's also going to have to skip over the hole in the graph. So the domain, and they have to be in order from smallest to largest, so the domain is going to come up to this hole in the graph and skip over the hole in the graph and skip over the domain. So copy that down, and I'll show you what it means when I'll do a quick sketch of it. Okay, so that's what a hole in the graph looks like. A big open circle. It's not big on the graph, but it's big on here to emphasize. There's a hole in the graph. This graph is going to go that way, and it's going to go that way, and then it's going to be over here. And so how far is it going this way? Not my problem. And it's going where? Positive infinity, and it skips over the hole, and it skips over. Yeah, don't leave that stuff on my desk. That's strange. All right, excuse me for that interruption. So, please look at example number 4. What did you do first? Did you factor correctly? What do you do next? Cancel. Where something cancels out. What cancels out? Where something cancels out of the denominator, that's where there's a hole in the graph. Where is there a hole in the graph? At 4 something. We'll figure out the rest of the hole in the graph tomorrow when we come back for the x values. We're just going to concentrate on the x parts today. Now, is there any denominator left? Now that that part been canceled out? There's not a denominator left. You know what that means? There is not an asymptote. That denominator that canceled out made a hole in the graph. There's not a denominator left to make an asymptote. What's the numerator that's left? Where you solve that, what's the x-intercept going to be equal to? Subtract 4 from both sides. The domain is going to go from negative infinity to positive infinity. It's not going to have an asymptote, but it is going to have to skip over that hole in the graph. When you cancel out that x minus 4, this is what you have left, x plus 4. Do you know what that would be if you graphed it? Do you know what x plus 4 is going to look like on a graph? Is it going to be a parabola? Is it going to be a V shape? Do you know what that it would be? Shake your head, yes or no. You know or you don't know. What is it going to be? A straight line. But what is that straight line going to have? It's going to have a hole in it. And we'll get our graphing calculators out in a few days, and you can actually see that little hole in the graph. Okay, did you factor example number 5 correctly? Did you get the numerator factored also? What's the first thing you do? Can you cancel anything out? Where you have something that cancels out, you have a hole in the graph. Can you solve x minus 1 equals 0? The x value of the hole will be 1. 1 something. We'll figure out the something tomorrow. Now, do we have a part of the denominator that's left? This x plus 5, this part that cancels out makes a hole. This denominator that doesn't cancel out makes an asymptote. What's an asymptote again? The graph is going to do what? It's going to come closer and closer and closer to the asymptote. But is it going to touch it? No. Hands off. Okay. And so subtract 5 from both sides. How do you find the x-intercept? Take the numerator, and it has to be equal to 0. How are we going to remember all this stuff? Well, read the chart. You know what to do. And so what's that equal to? 0. Now, we will come back and fill in the rest of these notes tomorrow. So on worksheet 11-2, you're going to factor first. You're going to figure out the hole, the vertical asymptote, the x-intercept, and the domain on all 10 problems. So on problem number 1, does it factor? No. On problem number 1, is there a hole? Did anything cancel out? So then what do you write next to where it says hole? And then you're going to figure out the vertical asymptote. X equals what? So you're going to go over here and you're going to write x minus 5 equals 0. That's where the asymptote comes from. You're going to skip the horizontal asymptote for now and you're going to come back to it. And then you're going to find the x-intercept. See, so it tells you right out there what to do. Solve the numerator equal to 0. What is the numerator? What's the numerator? Can 1 equal to 0? Not possible. What does that mean? There's not an x-intercept on this particular graph. Right? Word none. So the domain, it's going to be from negative infinity to positive infinity, but it's going to skip over what? The asymptote. And so it's going to skip over the asymptote. Now, I just happened in my previous class to flip over to the back and saw problem number 9 and thought, hey, you might need help factoring problem number 9. Am I correct that you're going to need help on factoring problem number 9? What do you notice about that denominator? Well, it's x to the 3rd power, but do you notice that every term has an x? So what are you going to do with that x? Not divide by it. You're going to factor it out. It does not disappear. It is still there. Then what are the factors of 2? Factors of 2 are 2 and 1. To make that negative, the bigger one has to be negative, and that one has to be positive. And so this would cancel out. Remember that when you're canceling out, this goes into that one time. So when you get down there to find the x-intercept on this one, is there any numerator left that can be equal to 0? So what are we going to have on the x-intercept on this one? None.